Hope you enjoyed that little break, and we're right back with our next caller. Hello, who am I speaking to?
Nayo?
Nayo.
Yes.
Welcome. Where are you from, Nayo?
From Letabile in Brit.
From where?
Letabile in Brit.
Okay.
It's in Pretoria.
Oh, fantastic. Oh, Pretoria is good. Right, Nayo, can you give me your question, please?
Yes. It says, find the gradients of the line that make the following angles with the positive direction of x-axis.
Okay, Nayo, I'm just going to stop you there for a second, just so that our viewers can just catch up to what you're saying. The topic is obviously analytical geometry. Okay.
Coordinate geometry, yeah. Okay.
Coordinate geometry is also called analytical geometry. Did you know that?
Okay. No, I didn't.
Okay. We're analyzing the coordinates on a Cartesian plane. So it's called coordinate geometry, but you'll see in your final paper, it will actually have a title that says analytical geometry. Okay.
Oh, yeah.
All right. So that's analytical geometry. It's the same thing as coordinate geometry. All right. Okay. And the question is to find the gradient of the line that makes an angle with the positive direction of the x-axis. Is that correct?
Yes.
Okay, great. So what I'm going to do for you first is to just draw a little axis to indicate what we're actually doing. So we have a Cartesian plane, and the positive direction of the x-axis is basically this direction from the origin all the way there. So that's the arm of the angle that you're looking at. And the negative direction of the x-axis is this arm here. That's the negative direction of the y-axis, and that's the positive direction of the y-axis. Okay. So just to understand what you were saying, find the gradient of the line that makes an angle with the positive direction of the x-axis. So now we have a line, right? And we can basically make a line. And let's say the line was over here, then the angle that they're referring to is this angle that goes from the positive direction of the x-axis all the way to the line. That is the angle that they're referring to. And I'm going to call that angle, I'm just going to call it theta.
They've given me degrees here.
Okay, so just one moment. Let me just follow through with what I'm saying. I'm defining everything that they've given you. So they have given you, number one, the positive direction of the x-axis. Are we sure that we know where that is?
Yes.
Okay. And then they've also given you a line that makes an angle with that direction. So the position of the angle is basically that. Okay. But now you're going to carry on.
Okay.
So find the gradient of the line which makes an angle with the positive direction of the x-axis. And what angle have they given you?
45 degrees.
45 degrees. Okay, so now, Nayo, the question becomes not just theta, but the line is actually making 45 degrees with the positive direction of the x-axis. So I'm going to redraw that.
Okay. Okay.
And we now have this happening, that there's my positive direction of the x-axis, and it's making an angle of 45 degrees. Now, 45 degrees is half of my 90 degrees. Okay? So I'm going to draw that line, 45 degrees. Okay? And the question is, what is the gradient of that orange line? Have you been given any theory around how to find the gradients of lines if you've been given the angle?
We've been given formulas.
Okay, what is the formula that you've been given?
M is equal to y2 minus y1 over x2 minus x1.
Okay, and what is that? What formula is that? y2 minus y1 over x2 minus x1. What does that formula give you?
The gradient of the line.
Okay, the gradient of the line. Now, Nayo, do you agree with me that that's not going to be very helpful over here because we don't have y2, y1. We don't have two y values. We don't have two x values.
Okay.
So do you see that if I write that down, y2 minus y1 over x2 minus x1, the question is to find m. Okay, over here we want to know what is m for this line. But, okay, m is just a gradient. But I don't have two y values and I don't have two x values. So this information over here is actually useless. It's not going to help me. Have you been given any other formula to find the gradient if you have an angle?
There's an example here that says MAB is equal to tan theta.
Okay. Do you know where that comes from?
No, I don't.
Okay, I'm going to show you. All right. If I take, if I just take another line over here, if I just do this, if I take this distance over here and this distance over here, right? And I just insert some values. If I take this length here as, let's make it A, and this length over here, let's make it B, then how would you define the tan of 45?
As MAB is equal to tan 45.
No. Can you see this triangle over here?
Okay.
What would the definition be of tan 45 inside that triangle? Do you know what the definition for tan is?
Yeah. I think.
Do you know what it is?
No,
Naya,
can you
I'm
tell
going to draw this triangle for you, and I'm going to call this theta. The side that is opposite the right angle, what do we call that side?
the adjacent side.
No. The side that's opposite the right angle.
The hypotenuse.
Okay, the hypotenuse. And the side that's next to the angle?
Is the
adjacent side. And the side opposite the angle is the opposite side. Now,
yes.
Neo, I want you to tell me. You see, I'm calling you, I've got the tangent and I've got Neo, so I'm calling you Tando, okay? Right, here we go. Neo, tan of theta, what will that equal to on this triangle over here?
Opposite over adjacent.
Fantastic, we've got that. Right, it's opposite over adjacent.
Okay.
All right. Now,
Okay.
I'm going to take you to the next page and I want you to find the definition for tan theta in that triangle. Okay?
Okay.
So in this triangle over here, okay, what would the tan, okay, here's my triangle, the dotted in pink with that, okay, and I'm going to put in a right angle there. That's a right angle triangle. What is the tan of 45 in this triangle?
Let me see. Adjacent over opposite.
No.
Okay.
Tan theta or tan of an angle is always opposite over adjacent. Always.
Okay.
It doesn't change. It's fixed. Okay, Naya?
Okay.
All right. So tan theta.